now explain the objective of the project. The main objective is to develop material handling system by integrating various sensor and actuation system by using Raspberry Pi microcontroller. It is also to expose students to how to wire and how to code, as well as how to successfully run the code and to do various applications. This is also to determine an operated material and system that can be performed to a set of coding by using Python language.
Hello, now I will show the component for the project. First we have the container with the metal plate. Next the conveyor belt, and then the relay to change the direction. Next PLC for the power supply, and then two proximity sensor to detect the metal plate. Next we have a single acting cylinder and three double acting cylinder. Next we have switch, the interface circuit, Raspberry Pi, breadboard, monitor, keyboard and mouse.
Hi guys, I'm going to talk about our wiring circuit, and first of all I would like to talk about the component that are included for this circuit. This is the PLC 24-volt supply, and this is a solenoid and a sensor that we are using, and this is a switch, and this is the interface circuits that are given by the lecturer, and this is a Raspberry Pi pin, which I simplified it so that the wiring can be simplified and easier to look. And first of all, I would like to talk about the ground circuit. In order for the system to be work, the ground circuit for the PLC, which is this black wire, and also the Raspberry Pi ground, should be connected so that the system can be in a closed loop and the function can be worked. Hence, by using a breadboard, I can parallel it the ground so that the ground can be shared to the PLC, Raspberry Pi, interface circuit, and all the solenoid and also the switch. After that, with the guide of a screw connector, I'm going to connect the PLC power supply to the screw connector, and all the solenoid and the sensor power supply will be supplied by this screw connector by connecting the wire as shown in this diagram. And for the sensor, the blue wire is connected to the ground as shown, and the input to the Raspberry Pi are stepped down by a potential bridge so that the voltage will be lower when connected to Raspberry Pi to prevent damage to the Raspberry Pi. And for the switch, there are two switches, which is black and red. They are connected to the 3.3 volts with the resistor to step down the voltage, and the switch is connected back to the pin desired so that the input value can be read by the Raspberry Pi. And then this is the interface circuit that I'm going to use. There are 12 GPIO and solenoid ports to connect to the solenoid, which is relay and also cylinder. And as shown in the diagram, the GPIO port is connected to the pin of the Raspberry Pi, and the solenoid is connected to the solenoid desired. And the ground is connected as shown so that the ground is in a closed loop. And overall, the circuit can be used by connecting like such in the diagram, and the function can be done.
Hi, my name is Ong Zhun Haw from Group M9. So today I would like to explain about the Python programming that we use throughout the project. First of all, we will import RPI.GPIO as GPIO, and then we import sleep function from time module as well as sleep function from system module. After this, we will define GPIO to each of the components that we want to control, and then we will do some GPIO setup whether the GPIO is used as input or output. And then we will initialize the condition of the 4 cylinders. We initialize them as high. This is because we need these 4 cylinders to be in extension condition in order to prevent the ping pong balls from popping out when we load the ping pong balls into the feeders. After this, we create a while loop. Inside this while loop, when we trigger the red button, the system will not be moving, and then we will need to reset the program again in order to start the system again. So if we trigger the red button without triggering the red button, the system will be started, and then the box will move towards right. And then we initialize n equal to 0, and this n is actually the total number of times the aluminium plate detected by sensors. So and then we create another while loop, which is while n less than 4. Inside this while loop, if the box is detected by the first sensor, n is count as 1. And then the box will stop moving and will go into this for loop. Inside this for loop, the first and second ping pong ball will drop into the box one by one. And then when 2 ping pong balls have dropped into the box will continue move to the right. And then when it is detected by the second sensor and is counted as 2, and the box will stop moving again. Then we'll go into another for loop. Inside this for loop, the third ping pong balls and fourth ping pong ball will drop into the box one by one as well. And then after the 2 ping pong balls have dropped into the box will move to the left for this time. And then this loop will continue to loop until n is equal to 4, and then when n equals to 4, it will go into another while loop, which is while n equal to 4. Inside this while loop, the box will stop moving, and then it means that the task has been completed, and then there should be 8 ping pong balls in the box already. Thank you.
Hi guys, now I'll be explaining how did we come up with the designable box for our project. First and foremost, the material that have been utilized in this box will be the polystyrene foam, the transparent book cover, and also a sheet metal, whereby the dimension of the box goes by a 15 cm of the length and 15 cm of the width and a maximum height of 14.3 cm, which enables the sheet metals to place in the position which is almost touching the proximity sensors to avoid any problem that might be encountered during the sensing process. Also, notice that there's only an upper lid that have been introduced at the front part of the box instead of the back one. This is because in the actual form of the system, the proximity sensor is always placed in front of the ping pong ball feeders, so there shouldn't be any obstacles here to in blocking the ping pong balls from dropping to the box itself. Thank you.
Hi guys, now I'll be explaining about the sequence of our material handling system. Starting from the left hand of the system, the box will be moving to the right side with the conveyor while it will stop under the first proximity sensor, which is the left one once the metal sheet on the designated box is sensed. Then, 2 ping pong balls will drop from the feeder, which initially held 4 balls in total. After that, the box will continue to move to the right end while stop under the second proximity sensor, which is the right one once the metal sheet is sensed again, where 2 ping pong balls will drop from the feeder as well. Then, the conveyor is programmed to move backward, which is to the left end to collect the remaining 2 balls in the left feeder using the same working mechanism as per mentioned above. Then, the conveyor is commanded to move forward to the right end to collect the other remaining 2 balls in the right feeder to collect a total of 8 ping pong balls at the end of the process. Finally, the switch is pressed in order to stop the process. To have a better understanding and picture of the process flow, let's watch a short video clip.